All right, great. Thank you all for sticking around for the third and final lightning round talk of the forum. My lightning talk on lightning round talks is 1.5 minutes, no slides, no questions, and I hope that you can all go visit them and talk with them about their research after the fact. And I hope that you will find them enlightening talks. Oh, boo. Okay, we're going to go ahead and get started with Katie. Come on up, Katie.
Good afternoon. My name is Katie Tsui. I am very honored to have this opportunity to talk to you about my summer research here at NASA Ames. I am an undergraduate at the University of Southern California, majoring in chemical engineering. Now, I am currently working with Dr. Michael Oy. I don't know if any of you know him. We're currently doing our research on graphene-based ultracapacitors. Now, for those of you who don't know, ultracapacitors are capacitors that can store a significantly greater amount of energy than your normal capacitors. They can also charge and discharge at a significantly faster rate. Graphene, on the other hand, is a single-layered sheet of carbon atoms arranged in a hexagonal lattice. They're highly conductive and extremely thin. What we're doing in our lab is to grow these graphene vertically onto our copper substrate and measure the capacitance of our substrates using cyclic photometry, which is an electrochemical technique that measures the current of our cell by applying a variable voltage. Right now, however, we're facing a little issues with the copper substrate due to its oxidation. However, we're actively working around this. Sorry. So our research is relevant to NASA and more specifically to Survey because ultracapacitors can meet the requirements of deep space missions, electric vehicles, and really any other applications that need energy storage devices. Again, my name is Katie Tsui. Thank you so much for your time. If you have any questions or comments, feel free to talk to me. I'll be here for the rest of the day, and thank you so much for your time.
Hi, I'm James Keene. I'm a PhD candidate at the University of Arizona, where I study planetary geophysics with an emphasis on tidal and rotational dynamics and planetary gravity. This week, I'll be presenting some new results developed in collaboration with the Survey Vortices team, in particular Matt Siegler and Rich Miller, where we perform a new analysis of the spatial distribution of lunar polar hydrogen as inferred by epithermal neutrons. In short, the spatial distribution of polar hydrogens aren't actually centered at the present-day lunar spin poles. Instead, they're shifted off by about 5 degrees, and the off-polar components are actually antipodal to one another, which to me, the rotational dynamicist just screams true polar wander. And so I'll be presenting a poster later where we go through that analysis, and I show that that particular polar wander path actually directly links polar hydrogen, or at least the polar wander itself, to the evolution of the Procolarum creep terrain. So we're using polar studies to inform internal geophysics. And we think this is really relevant to Survey, not only because it's a broad scientific study, but it's synthesizing the past 20 years of NASA missions, LRO, Lunar Prospector, LaCrosse, GRAIL, and it's also providing many testable hypotheses for basically every future mission, from geophysical seismic networks to in situ or return science, low altitude orbiters, and so on. So if you want to learn more about true polar wander, planetary gravity, have me pretend like I know what I'm talking about when I say epithermal neutrons, you can find me in the poster session. It's number 24. It's big and blue. I'm one of the 4 people here wearing a tie. So thank you. James Keene.
Vayai hippie, the Okishke Yunhe, Cara Moulton Machiapi 48 Matahan. Hello, my name is Cara Moulton, and I attend Sitting Bull College. I just introduced myself in Lakota, which is one of the languages on the Standing Rock Reservation where I live. Standing Rock is about the size of the state of Connecticut and straddles North and South Dakota to the west of the Missouri River, and Sitting Bull College has a student population which rivals the number of chairs in this room. Language and culture are among the major values of my college, but so is the environment, as we're located among one of the largest remaining untouched grasslands, and we were recently accredited to offer master's degrees in environmental science, which is what I study along with science education. Prior to Ames, I interned twice at NASA Langley working on atmospheric aerosol optical depth measurement instrumentation. And here at Ames, I'm actually working on UAS that could carry such instruments and even delivery payloads. I'm working in the aeromechanics branch with a team creating what we call Michael, a UAS capable of vertical takeoff and landing and fixed wing flight, but which can also self-compact and be driven across the surface. What I'm designing is the wings. Right now they're storable and plastered with gallium arsenide and actuated by complex pneumatics and maybe some piezoelectric. And though my poster is on an extended stay at the Printing and Export Control Office, I do have some copies. Actually, I based the design off of albatross wings, so they're pretty cool. And you're invited to come see me for a copy, or if you have an interest in partnering with a tribal college or a foothold in the Dakotas, or if you want to talk about philosophy of science or theoretical physics or ethos of exploration, as that's what I eventually would like to teach. Thank you, and Ampetu Washte. Have a good day.
I didn't know so many words were possible within 2 minutes. Hi, everyone. My name is Ben Hochman. I'm a third-year PhD student at Stanford University, just up the road. I work in the Aeronautics and Astronautics Department with Professor Marco Pavoni, and our project is with a team of JPLers, too, from planetary scientists to roboticists and technologists. And so the theme of this conference, or the theme of this forum, has been science that enables exploration and exploration that enables science. And I think what we've heard most about so far is the science that's been a product of the exploration. But as an engineer, I'm going to come at it from a slightly different angle and offer a new type of exploration modem to enable new science. And so the science we're trying to enable is in situ measurements on the surface of small bodies, which has been a very difficult task in the history of trying to visit small bodies for two particular reasons. One is the microgravity environment. The microgravity environment, 10,000 times less gravity than Earth. As someone put yesterday, it's not enough. It's not enough to neglect it, but it's too much to neglect it, but not enough to do anything useful with it. But we have proved that wrong, so to speak, with this new cube that we've developed. This is a prototype microgravity hopper that we've been working on for a few years. This is one of many prototypes we have. And the whole idea is that it's completely internally actuated, so there's no external moving parts. It's a sealed enclosure. And it can house a variety of scientific instruments for in situ measurements on the surface of small bodies. And unlike previous mobility approaches on the surface, this is a controllable idea. So there's been hoppers in the past that have sort of generated random motions, but this is going to enable scientists to target specific blue regions on Phobos or the like. So I'm giving a talk tomorrow at 2:30 about the ins and outs of how we do this and what kind of science it can enable. I also have a poster in the overflow room to the left of the speaker ready room. And I'm going to be doing a live demo of this thing hopping around during the poster session today. So if you can stop by, you'll see this thing moving around. Again, my name is Ben Hochman. Thanks for your time.
We heard from Evan this morning. That's a slight clerical error on my part. Sorry about that.
Hi, everyone. My name is Katherine Shirley. I'm a graduate student at Stony Brook University, and I work for Tim Glotch, so I'm part of the RISE team. My research focuses on mid-infrared spectroscopy, and specifically, I am looking at trying to see the differences between taking spectra in terrestrial conditions versus taking them in lunar conditions. And we use mid-infrared spectroscopy to identify minerals, so the fact that we do see a difference when we change the conditions can be problematic. So I'm trying to characterize the difference based on particle size as well, and we do see a variation when you get to smaller particle sizes of your minerals. So, you know, the moon is covered in somewhat fine-grained regolith, so this becomes important. And then when we're going out to asteroids, this is also useful in that aspect as well. So hopefully we can expand as we learn a bit more about this. I'm at poster 33 for that, and I have another poster at 71. I think Melinda Rux talked about this earlier this morning, we have created a public outreach program at Stony Brook where we go out into the community and we try to teach just small science lessons where they are doing some kind of activity, they can do hands-on experiments, and see that these are things that we do. We do science and we love science. Try to instill that message in these children before they get into middle school and are a little out of it. So thank you. That's at 71. And if you'd like to talk to me, I'll be at poster 71 or poster 33. So thank you, guys.
Okay, can we give one more round of applause to all the lightning round speakers from both days? And we're